Good afternoon, everyone. Welcome to this session on blockchain technology. I'm glad to say that we have two varied presentations waiting for you. One about what the title says, a game changer in commercialization of public data. We have Andy Wilson from Ordnance Survey from the UK talking about blockchain for land administration, so practical use case for blockchain. And second, we have Jonas Ellehauge, I hope I pronounced it correctly, from Denmark, who is a front-end developer and blockchain expert, who will surely talk about the technology behind blockchain. What is blockchain and what can you do with it? I'd like to introduce the first speaker, Andy Wilson from Ordnance Survey UK, to hold this presentation.
First of all, let me introduce myself. My name's Andy Wilson from Ordnance Survey. You may have heard of us. If you haven't, we're the National Mapping and Geospatial Agency of Great Britain. So we've been creating great mapping and geospatial data in Great Britain for around 228 years. So our main job in the UK is to create this living, breathing data set of digital geography. My role in OS is I work with nations across the globe in looking at national mapping process and how they might improve those processes and delivering services and solutions to help other national mapping agencies deliver better geospatial capability. And I'll come on to it in a moment what we're doing around land administration with our partners with Trimble. Okay. So here is the team. So we've got a team of three organisations looking at this challenge of land administration and how could blockchain potentially be a great technology to be deployed into a land administration solution and system. And what I'm going to do in this next 10 or 15 minutes is just explore the conditions for that, right? So let's see if blockchain is suitable for land administration. When are the conditions right for looking at deploying a blockchain into a land administration process? And I may be a little bit controversial in some of the things we say, but let's have a debate and we'll see where we go. So the team is comprising Ordnance Survey, a national geospatial and mapping organisation based in the UK, bringing great experience of geospatial technologies, processes, standards, and deploying the notion of building digital geographies across the globe and in the UK. Together with Trimble, this leading international geospatial solutions provider. And what we recognised a few years ago is that we and Trimble have sort of looked at the land administration market and decided there was something that needed to be done slightly differently. So what I hope I'll show you again through the next few slides is that we're looking at the digital land registry and the smart land registry as an ambition for the future, and we're creating a service platform that will help enable that vision, which in turn will provide the right conditions perhaps to deploy blockchain technologies. IBM are with us because of course they're a strong advocate of the use of these hyperledger technologies. So we've been getting some input from IBM into the story about the blockchain dimension being injected into a smart land registration process. So together with Trimble, we've been working for about the last 3 years in looking at this challenge of providing a different approach to land administration. So what we're doing is we're actually building a land administration service platform. So in effect, an end-to-end process of everything you need to do from registration through to registering multiple historic records and then deploying that in a system of registration on the ground with the citizens. And indeed, we're also looking at all of the dimensions that surround that ecosystem. So how do you capture the data that's required to support that digital registry? How do you collect these land parcels and that digital geography? How do you combine multiple historic records that may be in paper form into a single registry to ensure that that makes sense in terms of the epochs of different records that may exist? And we're also exploring the notion of taking finance with us to help those countries perhaps where they're not reliant on donor funding anymore and they're looking for a different, more sustainable solution in the delivery of that going forward. And we would say that this combination of services and offering creates the, if you like, that scenario of potentially going towards a smart registry, a digital registry. And that's the point when perhaps a registry becomes potentially ready for a blockchain approach. So, when are the conditions right to look at blockchain technology for a land registry or a land administration? We would say that really there are three key stages that you really need to look at before you can perhaps consider the use of blockchain technologies in that deployment. The first thing you need to do, of course, is sort out your data. That land administration may have lots of historic records in analog form and paper form. It may have lots of distant systems of use. So the first thing that we would suggest happens is a codifying of that data. So ensure that that data is put into a machine-readable format that's easily understood. So there's a bit of groundwork to do initially in codifying that data, codifying the title data, the rights, the restrictions, the responsibilities into that machine format that then the software can make those decisions on. The second phase is once you've got your data sorted out, is of course to create those digital services that sit around that data. So how do you provide that interaction with that ecosystem of people that need to interact with that data? So people that want to register their land, lenders of money, mortgage providers, all need to be able to interact with those digital services that land administration creates. So we would suggest that's the next condition really that you need to fulfill to ensure that you're going towards this notion of a smart land registry. And then finally, and perhaps sometimes the most challenging piece, is the legal framework. So, you may well sort your data out, you may sort out your digital services, but if you haven't got the legislative framework or the community or the vision from the government in that country, then it's going to be a tough job to actually enact this process. So probably the legislation change and the notion of legal digital signatures is probably the final stage. If you make all of those three stage changes, then I think you will realise those true ambitions of smoother, faster transactions. You're going to have happier people because their registration processes are going to shorten quite dramatically. And at that point, you could consider potentially injecting the blockchain as part of that digital register process. So, just sort of reiterating some of the challenges that we see in some of the land authorities we work with out there in the world. Those near-term challenges are really the ones that need to be addressed first. So sort out those paper-based records, look at some of those systems of computer systems and servers that may be in existence. There might be lots of silos of data that need to be connected better through a registry. So typically you'll see lots of different information flows that don't connect with each other. The technology can be very old, it can be very server-based, and it can be very difficult to deploy a digital registry from. And also, funding. There's financial constraints in many of these nations, so they can't have that catalyst to actually move forward in this way. And, it's just really we've heard a lot of hype about blockchain, and I think we just need to sort of have a reality check moment that, this is a good technology, but look, let's make sure the conditions are right before you even think about deploying it. So you could just say on the face of it, blockchain is going to give you faster transactions, your data quality is going to get fixed, you're going to have your legal issues sorted out and the like. But actually, look at what you're trying to achieve and look where the real value comes from. And we would say that's to enable those transactions when perhaps a single authority is not trusted to carry out those transactions. So of course that's the other, if you like, huge benefit that you get from a blockchain approach, is that you're spreading the trust and the risk of that transaction across several different agencies. So you go from just one organisation holding that responsibility as the land administration to a distributed network of trust across that blockchain. So everybody that interacts with that transaction is involved in that trust moment. So the lenders, the mortgage providers, the citizens that are registered in that land, the lands administration agency and the like. But of course, if you then move to this distributed notion of a land administration transaction network, the other thing you have to consider is that's probably going to change the whole nature of your lands administration agency in that country. It's going to be looking like a very different lands administration, I would argue, after you've deployed a blockchain process. So that's another major consideration, is you have to think about the structure and the makeup of the agencies and the different components of that blockchain ecosystem that you would operate within that nation. But of course, if you then solve some of those near-term challenges around the records and getting buy-in from the government and looking at the technology and everything else, of course, that will in the longer term address some of the longer term perhaps challenges and issues that we see, i.e. market liquidity and foreign investment willing to put their money into those particular nations. So again, by moving to a trusted blockchain transactional process for land in the long term, that may give confidence to foreign investment to plug into that country. So in turn, that could actually help out with sort of addressing some of the market liquidity issues that you might see today in some nations. So I think that's certainly something for the longer term, once you've realised the notion of a smart land registry with blockchain transaction technology. So what does a blockchain-based land authority look like? And here what we've tried to sort of outline is a top-level architecture really of what that might look like. So in the top line of the diagram there you can see that this consists of an ecosystem of citizens, lenders, interacting directly with the chain using this smart contracts philosophy. And so it's like a paper contract written in software which defines what each party actually has in that chain. And in the lower half, you'll see the blockchain itself is hosted by that network of distributed computers held by those different organizations across this ecosystem. So, final couple of slides, just really wrapping up here. I think our conclusion is, despite looking at the challenges that are in the early years or months of this process, we think there is value to be had in moving to this blockchain process. And the value is mostly in that increased trust moment. It's sharing that trust and risk across a distributed network. And we think that's where, certainly in many organizations and countries that we come across, there is a distrust between a single agency acting on behalf. So if a nation has that trust missing, then perhaps this is when blockchain may be an appropriate mechanism going forward. So is it worth doing? I think the question is that has to be really recognised on a case-by-case basis. It has to be an analysis of the structure of the nation, the existing frameworks, the existing data and how digital that is. What is the ambition for a digital land registry in that country? Can the legislation be changed? Is there an appetite in government for the vision to change that, if you like, that whole ecosystem? And if the answer to those questions is yes, then certainly we would say that this is absolutely worth putting on a roadmap for a digital land administration. And that was it. Thank you very much, everybody. Thanks for listening.
But first I'd like to introduce the second speaker of today, who is Jonas Ellehauge, blockchain expert, front-end developer at GRAS in Denmark.
Yeah, I'm Jonas, and I'm a front-end developer at DHI GRAS unit. And so that means that my daily work is with what happens in your browser, JavaScript, and that sort of thing. And our department works with satellite imagery. Here's the plan. So I'm going to give you a bit of context for why I'm here, some blockchain basics, look at some geospatial use cases, and then I'm going to dig a little bit into the foam project, which I find rather interesting, and eventually look at some of the relevance of all of this. So in 3 years ago, I had the chance to speak at 2 different conferences, back then for only 5 minutes, about this topic. And later I was invited to write for GM International about it. And a year later, I had a consulting gig for a company in Los Angeles. And last year I worked for 2 other blockchain companies. They had nothing to do with geospatial, but at least it gave me some insight to different business models around and the technology around blockchain. And then I was invited to speak here today. So yeah, let's have a look at blockchain. I mean, some of you may know the technology already. So very briefly summarized, it's a decentralized, immutable, peer-to-peer, trustless public registry or ledger or database, if you like. And I guess that should make it totally clear to anybody what it is, right? It really is hard, I think, to wrap your head around what it is. And so the most famous and also the first implementation of blockchain is Bitcoin. And so you've got these every 10 minutes or so there's a chunk of data called a block, which is added to the registry. Now I could actually use my notes, but I can't see them on this screen. Never mind. Each block contains a hash of the previous one, so a hash is like a fingerprint of the data, and that's part of the magic that it becomes immutable, right? You can't change existing entries once they've been entered, and the other part of the magic is that it's completely decentralized, so it lives on thousands of computers, and there's no central control. There's no one that owns it, right? And just to grasp that, let's look at the legacy financial system is where if Peter wants to transfer money or something else to John, or in this case money, it's actually his bank that transfers to John's bank, and eventually they have to clear or settle with a central clearinghouse. Whereas in a blockchain network, Peter transfers to John, and he just signs. It's a matter only between the two of them. He signs a digital message and broadcasts that to the network. He signs it with his private encryption key that he doesn't reveal to anybody. And anyone in the network can check that actually fits with his public key, and that it's valid, and they can add it to the ledger, so it sort of propagates through the network. So you could say that it's sort of an egalitarian or reciprocal network as opposed to a hierarchical one. Anyone can install the software and become a node in the network, and the incentive to do so is that the nodes are paid with transaction fees. So what this becomes is like a consensus machine, a consensus algorithm for anyone who wants to take part, and they sort of agree on the state of a shared record, and that's where the obvious use case is the land registry, because you want everybody in the area to agree on who owns what. The Ethereum blockchain is a general purpose one that has the currency is Ether, and you can program almost anything on it. So that's where the smart contracts come into the picture. They're like objects in a programming language. They also have APIs that you can interact with. They have methods and functions and properties like other programming objects. And they can regulate custom tokens. So you can have a custom utility token for a specific use case purpose. And so instead of running just transactions, it actually runs computations, right? So every time one of these smart contracts changes its state, see, that's where we come into the sort of this consensus about a shared state, right? It changes its state. Well, then you need to run computations on this blockchain, and there's a cost associated with that you need to pay, which is referred to as gas. There's very small amounts of ether actually. So the geospatial use cases that I talked about previously or wrote about were public good data and IoT and autonomous devices and land ownership. But I've come across a few new use cases in the meantime, which is to provide an alternative for GPS, proof of location and supply chain, and these are very closely tied together, these use cases. So let's have a look at the foam project. They have their own token on the Ethereum blockchain, and they made something they call cryptospatial coordinates, which is a new standard, short called CSC, that ties a smart contract on the Ethereum blockchain together with a location in the physical world. They also have a public good data project, which is called the SIV, which is like a community map, and then they have providing location and proof of location as an alternative to or improvement of the GPS functionality. So let's have a look at that. Some of the drawbacks about GPS. There's actually a TED talk about it also there's a central point of failure because it's owned by one organization and managed by them. It can be jammed. You can just, put up a jammer and then nobody can establish their location in the vicinity. Or you can spoof it, like pretending to be a GPS satellite, and then actually make someone's device give the wrong destination location. There's no indoor location, and there's also security and privacy issues, and you can't prove. You can have your device tell you where you are, but you can't prove to anybody else that you were there. There's a bunch of drawbacks that they're trying to solve. So how do we actually prove location in this respect? And to do that, I'm going to go back to the financial use case again, because that is, after all, where blockchain comes from. So how can you prove that digital money is yours? Well, when it comes to regular money, you ask your bank to verify it, who can in turn ask the central bank to verify it. And that's it. You just got to take their word for it, right? So here we're back at the middleman and the hierarchical system. Whereas if you want to prove that a specific Bitcoin or a fraction of Bitcoin is yours, you can sign a digital message. And anyone can prove that it is in fact yours by using, it's a mathematical objective proof. And so Foam is aiming at providing an infrastructure that can give you that kind of proof for your location in time and space. They're going to be using time synchronization and geometry just like GPS. Beacons that will be set up, not in orbit around the Earth, but just on buildings and anywhere really. And the idea is that people who put up these beacons could be anyone. They will be rewarded with crypto tokens, just like we know from regular blockchain mining, so that you have an economic incentive to take part and provide the service. A zone in this network consists of 4 beacons, so it can sort of establish itself, and then they start to synchronize their time with each other. And so if you pass through that zone of beacons, you can ask to have your location verified, and then that'll be cryptographic proof that you were there. And you can keep it to yourself in your so-called digital wallet, or you can choose to disclose it to anyone you want. So there is also solving some of the privacy issues around this. If you want to know more about it, there's a white paper and a bunch of interesting articles about it. So the community map, I'm going to go a bit fast through that. They call it the spatial index visualizer, and it's point of interest that are all registered in a smart contract. And what you got to do, anyone can add points to this map. You got to put something at stake, a little deposit of Foam tokens that you put on along with your point of interest. And if it turns out that that there's something wrong with that data, other people can challenge it, and you may lose your deposit. So again, trying to create the right economic incentives around this. So there's a very elaborate incentive system, and I think it's work in progress to make that function entirely. The main reason for challenging points on this map is wrong location, but there could also be other data, and usually rather fast. It's usually mostly within a week that only a small percentage of the data are actually the points are actually challenged. I came across another one where they have a slightly different model where they add the points. The points don't become visible immediately when people add them, but they have to be validated first by validators. So that's another project that is working on something similar. So how is all this is relevant? And I think it's not like we have the killer app around the corner, right? So it's really about providing the infrastructure for. And it's going to take a long time. OpenStreetMap, as far as I know, it took almost 10 years for them to really prove their worth, maybe 5 years at least. From it started, people were thinking, this is not going to work out, a community map. And then 10 years later, it's huge, and a lot of people are using it in their businesses. And you can say the same thing about Bitcoin. The first 5 years at least, it wasn't really worth anything, and it was only for geeks, and suddenly, it's taking the world by storm. But still, it hasn't completely changed the financial system, right? But it may within another 5-10 years, who knows? And I think that's the kind of long-term implications that I imagine around this, that either the Foam project or a similar project is going to come up with the right incentive structure to, give us newer and better GPS. And that's really what, at the end of the day, what makes a successful blockchain project is the incentives. If you manage to model real world incentives into the software, then it's gonna play out, and otherwise not, I think. So that was basically the end. Just want to mention that I read this book recently, and it's changed my view a little bit on blockchain, because by design blockchain is slow, inefficient, and expensive to use, which may not be very good for building other projects on it. But I think you can, that's maybe limited to Bitcoin. Then you can take parts of the technology and adapt it to other use cases, hopefully. But there's reasons for that, because they're trying to recreate the gold standard, I think, through software. But that's a different discussion. So thanks.
Thank you both for the two presentations on Bitcoin. I hope you have gotten a little better overview of what the technology is and what you can do with it. But of course, there are also questions and there are challenges to be solved regarding to technology. That's what the questions are about. We start with the first one. It says, blockchain is gradually emerging as a very reliable and effective technology for maintaining transparency and delivering services without any leakages. But are there any potential downsides that we don't know yet, or that we do know yet? Because I've already seen some slides in both presentations about the technology. Andy, may I start with you?
Sure, yes, I think it's probably the centre sort of message in my presentation is that the challenge is really about the technology may be getting there, and we know that it's accelerating, and in a couple of years' time it's probably going to be a de facto standard for digital ledger. But I think it's that notion of where people are right now with their technology and where they might be going in the next 2 to 3 years. So certainly our approach is, and I think will assist this, certainly the OS Trimble approach is we're looking at a cloud managed service, if you like, offered to try and address some of that legacy technology challenge. So instead of having lots of legacy architecture and deploying lots of heavy hardware and potentially software solution, we certainly recognise that a lot of jurisdictions that we work with are looking for a hosted service provision to address that problem. So that's something that we're actively looking at to try and overcome some of that legacy technology, is to deliver a different way of doing this from a subscription service perspective. So a lease technology platform that will enable some of these jurisdictions to move a lot quicker than they perhaps would towards a blockchain digital registry.
Jonas, what do you think are the challenges?
I think one of the biggest challenges about blockchain technology is that however reliable it is, it's hard to make that connection between the something that happens in the physical world and then something that's modeled on a blockchain, or any software for that matter. But it's because blockchain has been maybe oversold as this technology that can provide universal truth and independent of who the actors are. Trust us. And that's true as long as you're talking about something virtual like a currency, a digital currency. At the moment you want to prove physical location in physical space, or you want to tie it to a piece of land and say this piece of land belongs to someone in particular, then to make that connection between the ledger and the real world requires, there's no easy fix for that, at least.
I would sort of add that the other challenge, of course, is that property data tends to be quite large in its nature. So that's one of the other challenges, is trying to store that data on perhaps traditional systems is the challenge. So absolutely the move to a cloud version of hosting that data is probably the answer, because the data volumes associated with property transactions tend to be quite large over time. So that's the other consideration. The technology right now is probably not dealing with that in the way it should.
And whose responsibility is it? Is it something for tech vendors? Is it something for people who write legislation, or the organizations dealing with the data? All of them.
All of them probably is the answer. Yes.
Yeah. I think at the end of the day, it's what people adapt. And right now, this is pretty complicated stuff. to just to acquire some crypto assets and to manage them safely is still mainly for geeks, right? So when you see widespread adoption of this technology, I think the systems are going to add up to the demand.
Is that a question of larger demand?
Yeah, that's what I think.
Yeah.
We come from. I mean, you're in the regulated world or in the government world, and I'm not. So I have a different, maybe the bottom-up perspective that I believe that the change comes from when people demand something, then it'll come into existence.
Yeah, that's also the second question on my paper. Said, should governments incentivize blockchain technology, and how could it be done in an innovative manner? Is the role for governments? Yeah.
I guess the obvious one is shortening the system of land registration. So again, as per my talk, if you can get to that blockchain notion, you should be able to shorten the transaction significantly. So in some countries, I've typically seen transactions of months. It can be 9 months before the start and end of a registration of land. So typically, a lot of countries want to get that down to a matter of days. So again, that's a major incentive. If citizens are struggling to get good registration and quickly, then certainly this is an incentive if you want them to get that land registration record very quickly. And again, create confidence in the market that property value is correct and that the right records are being used for that valuation.
And what the question was,
how
should governments apply it?
Yeah, should governments incentivize
incentives?
Yeah. I think one of the wonderful things about it is that it's public by nature, right, and no one owns it. So I think if it's the more governance services that you can make more transparent on a blockchain, whether it's public spending or whatever, I think it's a benefit because there is no gatekeeper as such, right? All transactions are public. Anyone can inspect them the way they want and see what's been going on. And there's no gatekeeper. You don't ask for permission to see the data. It's just there. That's why I think it's good to implement in practically any governance services you can imagine, if it's possible.
That's about the government, but what about tech companies? Because you mentioned foam, for example, as an example of location-based services combined with blockchain technology. But how does that work? Because they have an how you say they want to make money on that. One of the larger goals of foam is to create a map, like a Google map, that can be used for other types of applications. So if we look at blockchain and location-based services, how can blockchain play a vital role in location-based services, for example, foam?
What was the how you mentioned last?
How can blockchain play a vital role in location-based services? Because how we have foam, how far is the project, or how far?
I think it's going to be years before you see that turn into something that you can use in your daily life. They're providing an infrastructure, and other people will build applications on top of it, presumably. So,
and
I think proof of location is something that I know big what they call container ship companies like Maersk and others along that line are investing heavily into blockchain in order to, make their proof of location is good for them because they can prove where things are in space and time, and it makes their workflows more efficient and transparent.
And I think, just going back to the other dimension of incentives, and you could see this as maybe a incentive versus disincentive depending on your point of view, and some of the, if you like, the benefits is that we would say that, going back to the land administration context, hand in hand comes the notion of digital identity at the personal level. So this only works if the country is prepared to actually give everybody a digital ID, because you have to be absolutely sure of who that individual is in the chain and in the register. But of course, some countries have adopted this notion of national ID as a way of managing lots of their policy processes. So there's a lot of benefits that come out of national ID registration. But of course there is also the other side of it, which people don't like, that big brother type aspect of actually being registered against a digital ID. So depending on your perspective digital IDs are going to be a big part of blockchain as far as the individual identity goes.
If you look at geospatial technology, we have geospatial technology vendors. I was very surprised to read an article online where it said a vendor said, well, maybe you, I mean, blockchain may not need GIS, but as an end user, you could use a geospatial system to extend blockchain to add location-based services type to it. So then the question is, how can it will it replace geospatial technology, or how do you see this? How do you see blockchain and geospatial live one next to another?
I think they're complementary. I mean, my gut reaction is they feel complementary, and that one is enabling the other. I mean, you need geospatial technologies pretty much for everything that you do in government, and I think blockchain is effectively just a complementary technology that allows absolute identity and transaction registration and confidence that that transaction is who it is and where it is. So for me, they are complementary technologies. I don't think one will destroy the other.
No.
Yeah, I pretty much agree that it's complementary. Yeah, it's not going to wipe out the whole geospatial industry as such.
No. Okay. Maybe there are questions from the audience for both speakers. If not, we'll wrap up. We're just in time. 1:45. So.
Was there one question? If we have time for it, that's the question.
Well,
Yes.
quick question.
Yeah.
We have a panel right after this.
Okay.
One question only.
Once I spoke to the Dutch government, the agency, they say that they were kind of, at this moment, rather negative toward the whole blockchain technology because of this energy consumption point. I don't know, how would you respond to that kind of comment?
We don't have a whole lot of time. Like I said, the blockchain technology as in Bitcoin is expensive and meaning energy consuming, yes, and slow and inefficient. Like gold mining is. And that's why gold is good money, because it's not easy to make more of it. And that makes it very trustworthy, but also makes it unsuitable for buying your daily coffee. You wouldn't buy that with a chunk of gold. So it's a final settlement layer. And that's the same thing here. Actually interacting with the blockchain as such is rather expensive. So you want to try and settle as much as you can outside of the chain, and then eventually you can use that as a final settlement layer. I think you'll see that a lot in different types of applications.